We have three logarithmic equations to solve. Let's start with the green one. We have log 2x minus 1 minus log of x equals to 2. So that one requires you to use the first formula, log a over b equals to log of a minus log of b. These two logs, they have the same base. By the way, when the base is not specified, that means the base is equals to 10. Okay, first step, I would like to apply the formula immediately and then write this as log parenthesis 2x minus 1 divided by x, and then that is equals to 2. Like I said, when the base is not specified, it is 10. So we will be taking the base 10 raised to the second power equals to 2x minus 1 divided by x. So that's the next step. And then what do we do next? We will just multiply x on both sides. The 10 squared is 100. So multiply x on both sides. You have 2x minus 1. Wow, we can easily solve for x, right? So 100 minus 2 is 98. So we have 98x equals to negative 1. And then x is equals to negative 1 over 98. Is this a solution or extraneous solution? It is pretty simple to check. I will just plug it in. So let's check. Plug in. So I have log, and then I can plug it into. Here, right? So that is a negative 2 divided by 98 minus 1. And then how about the other one? Minus log of negative 1 over 98 equals to 2. So this is negative. And this is also negative. Is log of negative defined? The answer is no. They are undefined. So even though we did all the algebra to get to the conclusion that doesn't work, then this is called an extraneous solution. Extraneous solution. Okay, moving on to the orange one, the ln. I have ln 5x plus 1 equals to this ln plus that ln. So we are adding two ln. So ln A plus ln B, that is equals to ln AB. So the orange problem is ln 5x plus 1 equals to ln. You add them, that means you multiply them to 2x plus 3, and then you multiply 2. And then we will just distribute the 2. We have ln 4x plus 3. The left-hand side is ln 5x plus 1. So each side is ln of something. Okay, so what that means is we will use the 1-to-1 property. So 1-to-1 property. That means everything inside the parenthesis is equal. That will be 5x plus 1 equals to 4x plus 3. X on the left, so 5x minus 4x equals to 3 minus 1. So that is a 3 minus 1. This is a x equals to 2. Do you think that will work? Let's plug in. So plug it into the 5x. So we have a 10x plus 1. No, not 10x plus 1. We have a 10 plus 1. No, 5 or 4x. So 4x. Hold on. Did I make a mistake right here? Oh, you know what? Maybe you're right the whole time. I was wrong the whole time. 3 times 2 is equals to 6. Okay, so this is a 6. 6 minus 1 is equals to 5. 6 minus 1, that is equals to 5. Okay, you are right the whole time. When x is equals to 5, 5 times 5 is 25. 25 plus 1 is 26. So on the other side, I have ln. And then you can do, you know what? You can plug it in the 5 to here. So 5 times 2 is 10. 10 plus 3 is 13. And then you have ln of 13 times 2. So you have 26 equals to 26. So this is checked, and this is a solution. Solution that works. Last one, the purple problem. We have ln x plus 2 minus ln x equals to 2. So ln minus, the minus will be this one, except you change the log to ln. So that will be a ln x plus 2 divided by x equals to 2. And then what is the base of Ln? The base of Ln is e. So you have base e raised to the second power equals to x plus 2 divided by x. And then to get rid of the fraction, you multiply x on both sides. You have xe squared equals to x plus 2. And then I will move all the x to one side, to the left side, and then factor out the x. So that will be xe squared minus x equals to 2. And then you factor out the x. This will be a e squared minus 1 equals to 2. So x is equals to 2 divided by e squared minus 1. That is the exact value. But is that going to work? I will just use the approximation. So this is approximately equals to 0.31. And then you can plug it into the equation. You can plug it into here. So you have ln 0.31 plus 2 divided by 0.31 equals to 2. So this is a check. Since you use an approximation that is not going to be exactly the same, so this one I end up with 2.0084 equals to 2. They are pretty, this one I accept that because the 0.31 is an approximation. So therefore, we can call this a solution to the logarithmic equation. All right, so that is the end of this video. If you like the way I explain logarithmic equation, thumbs up, subscribe, and I will see you all in the next one. Signing out.